A very good morning to Sir ZULKARNAIN. My name is MUHSIN bin ROSLI. Today we are going to present our HVAC design assignment, which is to design the refrigeration system. For our group, we are tasked to design the cold room. So, what is a cold room? A refrigerating chamber or cold room is a warehouse in which specific temperature is artificially generated. It is generally designed for storing products in an environment below the outside temperature. The objective of the project. The objective of designing a cold room is to be focused on operation and manual for heating, ventilation, and air conditioning system of the cold room. This objective help us to learn about more the cold room principle of refrigeration and equipment. For the next slide is the flowchart design. First, we brainstorm 2 or 3 drawing that we brainstorm. Then we select the best design to draw in the software like SolidWorks. Then we do an analysis on the drawing. Before we do the analysis, we select the material for the drawing design. Then after we get the report of the analysis, we proceed to write a report on the design we just create. Next is the background of the equipment and accessories. The cold room have 6 main components, which consists of compressor, sealing unit cooler, electronic control box, cold storage, cold air wind curtain, and air cooler condenser. So for the next slides, there is more to know about cold room. There are types of cold room that I found via my research. First is remote cold room. A unique feature of this cold room is that the compressor are installed on the outline like the most refrigeration system. Coolant is transported from a condenser to the compressor through a line. And next cold room is penthouse cold room. This type of cold room is provide sufficient space for storing in the refrigeration. As a result, you will have more space for capacity racks and efficient fan systems installed in penthouse cold room. And the next type of cold room is centralized cold room. Centralized cold room are usually installed by a large company to fulfill complex refrigeration requirements. Users are able to control such system via mobile application, which makes it easy for them to operate their business remotely. And lastly is flake and block cold room. A flake and block cold room has highly efficient design that is suitable for both general and industrial purposes. It is often marketed as an all-in-one solution because even a small-scale business can rely on a customized flake and block cold room. That's all for me. Thank you and Assalamualaikum.
Good morning to Dr. ZULKARNAIN. My name is SASITARAN from BMMH3573. Today I'm going to tell about how the cold room works. The cold room is a temperature controlled space for storing perishable items at specific temperature range of 33 degree to 40 degree Fahrenheit. The refrigerant cycle is used to remove heat from inside the room and transfer it outside the refrigerant unit. Includes compressor, condenser, evaporator, and refrigerant. Refrigerant absorbs and releases heat as it changes from liquid to gas and back to the cold. Refrigerant cools the air inside the room and creates a temperature controlled environment. The cycle of compression, condensation, evaporation, and expansion allow the refrigerant unit to maintain desired temperature. Cold room also include insulation, control system, and air circulation system. Cold room can be used for various purposes such as storage, preservation, and laboratory samples, meat, fish processing. Cold room can be customized to suit specific industry needs. Next, we see the design of cold room. This is our design of the cold room. We took reference of the cold room at the HVAC application lab at our AIMAN and made the drawing using the SolidWorks software. The designing or recreate of a refrigerated cold room may have slight changes in terms of dimension and structure of the cold room. After we design the cold room, we see the structure analysis result of the cold room. First, we see the Warm Mises stress. The Warm Mises stress is also known as the equivalent stress or total strain energy density. It's a measure of the stress state at a particular point in the material that is undergoing complex loading. Now we see here it has a minimum of 1.915 times 10 to the power of 0 Newton meter square and maximum of 1.493 times 10 to the power of 94 Newton meter square. Next, we see the structure analysis result for the displacement. In the structure analysis, displacement is a measure of the change in position of a point in a structure related to its original position. It is a vector quantity, meaning it has both magnitude and direction. In here, we see it has minimum displacement of 1.00 times 10 to the power of negative 30 and maximum of 9.591 times 10 to the power of 2. After that, we see the strain structure analysis result for the strain. Strain is a deformation of the material from stress. It is a simply ratio of the change in length to the original length. It has a minimum strain of 2.805 times 10 to the power of negative 5 and maximum strain is 3.463 times 10 to the power of negative 1. And finally, we see the structure analysis result. Factor of safety. Factor of safety is a ratio used in structural analysis to determine the strength of the structure in relation to the load it is expected to bear. We see it shows straight. It is typically indicated the design structure or component is operating at or near its failure limit. The factor of safety is a ratio of the material yield strength or ultimate strength to the maximum stress the structure is experiencing. So if the FOS is less than 1, it means the structure is less greater than the material strength, and thus it is the state of failure. So in this case, we have the first factor of safety is less than 1. So it has the minimum factor of safety is 3.350 times 10 to the power of 0 and the maximum factor of safety is 2.611 times 10 to the power of 4. That's all from me. Thank you.
Assalamualaikum sir. My name is AIMAN ROSLI and I will talk about installation procedure and manual. Firstly is the site preparation. The first step is to prepare the site for the installation of the cold room. This includes leveling the ground, laying a concrete slab and installing a necessary electrical and plumbing connections. Next is insulation. The walls, floor and ceiling of the cold room must be insulated to prevent heat transfer from the outside. Thirdly is framing. The walls, floor and ceiling of the cold room must be framed using structural materials such as wood or metal to provide support for the insulation and the interior finishes. Fourth, the interior finishes, which the wall, floor and ceiling of the cold room must be finished using materials that are suitable for use in a refrigerated environment. This typically includes using stainless steel, aluminium or other corrosion-resistant materials. Fifth, refrigerant unit installation. The refrigerant unit, which include the compressor, condenser, evaporator and even refrigerant, must be installed and connected to the cold room. Next, control system installation. Control system must be installed to regulate the temperature and humidity inside the cold room. Next, the air circulation. A system for circulating the cool air inside the cold room must be installed. This typically includes the installing of ductwork and fans to distribute the cool air throughout the room. And lastly, testing and commissioning. Once the installation is complete, the cold room must be tested and commissioned to ensure that it is operating correctly and the temperature and humidity are within the desired range. Next, I will talk about safety precautions during installation and maintenance. When working in a cold room, the most common cold room illness are the greatest concern. Low temperatures can make the work uncomfortable and increase the possibility of various illness, which can further impair performance. Example of cold room illness are frostbite, frostnip, hypothermia, and also immersion injury. There are few safety precautions. Firstly, cold room precautions. Depending on the cold room operation, different precautions will be implemented. The precautionary measures that we have outlined have been recommended by several UK boards, including the British Frozen Food Federation and Health and Safety Executive. Firstly, you need to monitor the workplace temperature. By monitoring the temperature and air movement in all cold areas on every shift, at least every 4 hours. Next, the engineering control, which we need to construct facilities or include equipment such as radiant heaters, warm plates, and air jets that will help to warm the workers inside the cold room. Next, we need proper working clothing and protective equipment. The appropriate clothing and equipment should have always been worn when working in cold environment. And last but not least, we need proper training and healthy work practices. Workers should be educated about the symptoms of cold room-related illness. Supervisors also must ensure an appropriate rest period for each working schedule. Safety measures can help both employees and the company to perform safer and better operations. That's all for me. Thank you.
Good evening, everyone. Now I am going to explain for our discussion for our group, which is the cold room. So first of all, technique to improve design failure during analysis. So the first one is the device has to be studied to improve its durability. Some material was way too expensive and would detract from the cost, which was also a necessary specification in the design. The second one, which in implementing the design, the team which us has to change the original dimension due to change in the size of the desired room. The process was very tedious and time-consuming as the team had to keep changing the dimension of the cold room. The team has taken some measures to improve the performance of our design. First, we communicate frequently so that the team would understand what was needed in the project. We were able to learn project management as an integral part of engineering. The team was able to learn how to use SolidWorks software to do analysis on everyday project. The design shows us how to manage and use resources efficiently without wasting money. We had also learned to work as a team and use the time allotted to work on each project. So finally, we move into the conclusion. So first of all, in this project, not project report, we can conclude that we did design of cold room, the analysis, and we realized that our design needs more improvement to make sure all our users is satisfying and comfortable using our product. Nevertheless, when we are doing this project, we know that we need to create a design that need to be at low cost. In other terms, a lot we have learned through this subject, BMMH3573, Refrigeration System Design. First, we learn how to sketch 2D design in SolidWorks and convert the sketch into a 3D design. Next, we have generated ideas based on given problem, which is designing cold room. We also learn the equipment and accessory used to build cold room and safely precaution during installation and maintenance of cold room. That's all. Thank you. There are several ideas you can use to improve the cold room. The first one is insulation. Proper insulation is crucial in maintaining the desired temperature and preventing energy loss. High density insulation materials such as polyurethane foam should be used to ensure optimal insulation. The second one, which is airflow. Proper airflow can help prevent mold and bacteria growth, as well as ensure that the store goods are being cooled or frozen evenly. This can include using fan and duct to circulate the air using when to exhaust warm air. And the third part, which is material. Choosing appropriate materials that can withstand the extreme condition of a cold room and can resist